Figure 8 shows, so this is question 15. Describe how the speed and total energy of the comet vary as it moves around its orbit from X to Y. So this can be a bit daunting unless you understand what's going on by gravity. So what we want is, so here's a way to kind of figure out things if you don't really know what's going on. We want speed. Okay? Ignore total energy for now, because total energy is gravitational energy, gravity plus kinetic. And in any situation where we don't lose energy, it'll stay constant. Basically, the gravitational energy gets converted to kinetic and the other way around. So you can think about it in two ways. First of all, we can figure out speed. What do we have here? Speed in terms of the radius, because the mass is staying the same. So if we had gm1, that's our planet, 2 equals v squared on r. So this is the formulas for the acceleration or the gravitational field. They're all equal to each other. So if you want mass to velocity, you can do it like that. So we get this, or we get v squared equals, we bring the r over, gm1 over r. Therefore, if the radius gets bigger, velocity gets smaller. If the radius gets smaller, velocity gets bigger. We can also see this as potential energy, potential energy, but don't worry about that. So, therefore, at point Y, our asteroid, our comet fast, point X, comet slow. So from X to Y, comet gets slower, while total energy equals constant. Easy. Okay, blah, blah, blah. So we have mass and radius. This material is not supplied. Calculate the force on the Mars Global Surveyor. You must show you're working. So there's a planet, Mars, and here's our surveyor. I want to figure out the force. So we just use our gravitational force. Force is this. This is in terms of mass, in terms of velocity, in terms of period. What do we have? We have mass. Easy, we just use our mass formula. Force equals gm1 m2 on r squared equals g 6.67 times 10 to the negative 11 times m1, which is the big mass, 6.42 times 10 to the 23 times 930 over r squared, 3.83 times 10 to the 6 all squared. Now this looks pretty daunting, but we can simplify it a little bit, because that becomes 6.67. We can cancel this with that. Minus 11 becomes 12 times 6.42 times 930 times 10 to the 12 over 3.83. We can bring out the square and make that, because that becomes 3.83 squared times 10.6 squared. No, 10.6 all to the power 2 becomes 12. Now you can cancel that and that. Much easier, because I don't like working with big zeros on calculators. I usually make mistakes. 6.67 times 6.42 times 930 divided by 3.83 squared equals 2,714.85 newtons. Right. And calculate the period or orbit of Mars. So we want the period and we have the mass. We just need to go from period to mass. Okay. So we want period, we take the t squared over, and we bring everything else. I'm bringing this up to there, bring this down to here, bring that over to there. That's how you do maths. If some of you are a little bit confused by that, it's a little bit, you just have to practice it. So the t squared's up there and the gm's down the bottom. For t, it's the square root of this junk. What is this junk? I don't know. But let's try and do it, because it's pretty complicated to do sometimes. So I'll do the top part first. 4 times pi. Pi squared times, what's the radius? I'll do it on this page. 4 pi cubed on gm. This makes it easier for me to write. Times power 3 times 10 times 10 power of 18. Top equals 2.21797 times 10 to the 21. Now on the bottom we have g, which is 6.67 times 10 to the power of negative 11 times mass times 6.42 times 10 to the power of 23. That equals 4.2821 times 10 to the 13. So now we just need to divide them. I messed that up. 2.21. I divided by 10 to the power of 23. So it should have been 10 to the power of 13. So I have issues with this, I'll be honest. I think you guys can do much better than me. I can do it my way, but I don't know if you'd be able to do it my way. But it equals that. So that was embarrassing. But that's the answer. And then you take the square root of that. T squared equals that. T equals 7196.97. Or 7197. And we're done. Thanks.